Hello friends, now let us see a simple question on electronic configurations based upon the three principles. It is given as, the question is given like this: the principle violated in the given configuration. It might be above principle, Hund's rule, or Pauli's principle, or of these all are correct. Let us check once. First, let us see observe the electron configuration. It is given 3s and 3p subshells and some electrons occupied here. If you observe 3s subshell, it is singly occupied and electrons entered into 3p. We know according to above principle, electrons will occupy the lower energy levels first. After completely filling the lower energy levels, they enter into higher energy levels. But if it is observed here, without completely filling 3s orbital, electrons entered into 3p subshell. This is controversy to above principle. That we can say above principle is violated in this configuration. That means without completely filling the lower energy level 3s, electrons entered into higher energy level 3p. So above principle is violated in this configuration. Let us observe in the other way to understand whether Hund's rule is violated or followed. If we observe here this 3p subshell configuration, there are three degenerate orbitals. According to Hund's rule, all the degenerate orbitals should occupy first with a single electron, then only pairing should taking place. But if it is observed here, without filling one of the three degenerate orbitals, without even filling with a single electron, pairing of electrons taking place in the remaining two orbitals. This is controversial to Hund's rule. That means it doesn't follow Hund's rule here. It is violating Hund's rule too. It means all the degenerate orbitals first should occupy the single electron, then only the remaining electrons will come for pairing with the single electrons there. So Hund's rule is also violated. Let us see whether Pauli's principle followed or violated. According to Pauli's principle, no two electrons in an atom should have same set of quantum numbers. That means in the other way, only two electrons can be accommodated in an orbital, and that too with opposite spins. But if it is observed here, one of the 3p orbitals is having two electrons, very good, but both are in the same direction. From this, both these electrons will get the same set of quantum numbers. The electrons in the same orbital will get three quantum numbers the same anyhow. Principal quantum number, azimuthal quantum number, and magnetic quantum number will be same as they are being the same orbital. They will be differed in spin quantum number because they will be in the opposite directions. But here, differently given, two electrons in the orbital have the same spin. Then these two electrons will get same set of quantum numbers, which is the violation of Pauli's principle. So compulsory there will be two electrons in an orbital if existing. If there are two, there will be the opposite spins. But here both are given in the same spin, so this is violation of Pauli's principle. So in this way, three principles are violated in this electron configuration. So here for this question, correct answer will be all of these. Means three principles are violated. Such kind of questions will be asked in the competitive examinations based upon the electronic configurations.